G'day, Alucard J here. In this video I'm going to make another static utility script. This will be a collection of filters that you can modify an array of noise with. Now earlier on I already covered a couple of filters, the turbulence and the exponential filters. So I've already gone ahead and typed the script out, and I'm just quickly going to go through each function, and then we'll go on to another video where we can actually use this with noise to see what kind of more complex noise that we can create. So the first one is our turbulence, where the value was less than half, it would inverse that to give a more bumpy kind of output. You have the exponential, which will greatly reduce lower amounts of noise. Then we have a new one here, flatten. This is basically a very simplified exponential filter. It takes the value and it multiplies it by itself. And then for the number of iterations we have here in our optional parameter, it'll keep multiplying it by itself and multiplying by itself. So if you imagine you had a value of 0.5, you times it by 0.5, you get 0.25. If you did that again, you get 0.125, and so on and so on. So it's basically a simplified exponential filter. Then I have a smoothing function here, which is a simple diamond square smoothing technique. If you have a pixel, and then you take the 8 pixels that are surrounding that one pixel, take the value of each of those, add them together, and then divide by 8. So you're taking the average of all the 8 pixels surrounding it, and return it as a value. And again, there's a parameter here for the number of times that you do this, how many iterations you do. Make it smoother and smoother and smoother depending on how many iterations. And finally there's a function here. This is for the Unity's terrain system, because if you wanted to apply your noise to the terrain, you'd find that the terrain's height maps take the X on the vertical axis and the Y on the horizontal axis. So this way we could just make our noise, pass it through the flip axes, it'll plot all your X's with your Y's, and then apply it to the terrain, and it get the same output on the terrain as you would see in a texture. So there are a whole collection of single filters that you can use on one array of noise. So now I have just a couple of blend filters where we take in 2 noise arrays and blend them somehow. So the first one is a blend multiply, where it simply multiplies a value from noise A with the same from noise B, the same index. There's a whole bunch of equations here. Now this is just some overkill, some checks to see, just in case you pass float arrays of different sizes, so that you don't get a null reference array out of range index error. So that's what all this extra stuff is. But basically that's all this one does. Index 0, 0 of noise A, I'll multiply that by index 0, 0 of noise B, and so on through every index. And then we have a blend additive. Same thing with the checks for the array out of range exception that you might get from 2 different size arrays. Take a value from noise A and a value from noise B, but you want to get a value between 0 and 1 out of both of them. So I have a float here called bias, which is how much of noise A do we add to noise B. So C is a default optional parameter here of 0.5. So if we took half of noise A and half of noise B, just say these were both 1. So we'd have 1 times a half equals a half, plus 1 times a half equals a half, which would equal 1. So we've still got our range between 0 and 1. And that's all it's basically doing. And then you could play around with the bias, like just say you wanted 20% of the value of noise A. We would bring that down to, or it's actually 0.5, so it would be 0.1. And then you would get 80% of noise B, so that will give it a stronger bias towards noise B. So that's all that does. And anyway, like I said, I just wanted to make this quick, because people are going to grab the script anyway, and I'm more interested in finally putting all this stuff together and showing how it can be used to generate complex noise, and then we could apply it to a terrain.